Hello everyone. Today we will discuss about the zeroth law of thermodynamics. To understand that, we need to study an experiment which was conducted before this law was formulated. So for that, let's consider a container in which there are three systems which are separated by different type of walls. This A and B system, which I am marking here, this is A and B. These are separated by adiabatic wall. Adiabatic wall means no heat exchange is possible. Right? And these are separated by a third system C by a wall which is called as dithermic wall. Dithermic wall means heat exchange can take place. So what happens is that during this experiment, there is the possibility of heat exchange between A and C and B and C. So what happens due to heat exchange, after some time it is observed that these are in thermal equilibrium. Then after when this adiabatic wall was removed, it was observed that there was no heat exchange, right? So that means it was concluded that since A and C and B and C were in thermal equilibrium, so it was concluded that A and B were also became in thermal equilibrium. So a common statement was given that if two systems A and B are separately in thermal equilibrium with a third system C, then A and B are also in thermal equilibrium with each other. So what were the steps? A and C and B and C. Exchange of heat takes place, and in this case also exchange of heat takes place. Then after adiabatic wall between A and B is removed, right? And it was observed that there was no exchange of heat between A and B. Right? What does that indicate? It indicates that A and C attained thermal equilibrium till the heat exchange brought them to thermal equilibrium. Similarly, B and C also attained thermal equilibrium, right? So this resulted in thermal equilibrium of A and B. So from this experiment an inference was given, and that inference is given in the form of zeroth law of thermodynamics. So what is zeroth law? This is actually the inference of this experiment. So what does it say? It says that if two systems are separately in thermal equilibrium with a third system C, then A and B systems are also in thermal equilibrium with each other. This is zeroth law of thermodynamics. So what is its significance? Actually, it gave the rise to the concept of temperature. That temperature is that quantity which remains same for the systems which are in thermal equilibrium. So its significance is it gave the concept of temperature. Okay, temperature is that physical quantity which remains same for the systems in thermal equilibrium. So on the basis of this, temperature can be defined as and this law is called as zeroth law because this was formulated long after the formulation of the first and second law of thermodynamics, but it gave the definition of a fundamental quantity called temperature. So that's why this is given the name zeroth law. So this also I will mention here, the reason for the name zeroth law. Okay, so it was given long after first and but it defines a fundamental quantity called temperature. And it was given by Fowler, right? So this was all about the zeroth law of thermodynamics. Hope you understood it. That's all for now. Have a nice day.